So far, we have seen how to use simple variables to store information. For example, we have seen how we can use a variable to store the number of items, the price of a given item, so on and so forth. Now, in the real world, we have another scenario that is also plausible and possible, which is, we have a group of interrelated variables or a list of variables. For example, the list of all the grades of the students in a given class, the list of the social security numbers of the employees of a given company, so on and so forth. So whenever we need to represent a list, we need to use a data structure for that, and this data structure is in the case of C++ is the most appropriate one. The simplest and most obvious one is actually the array. Okay, so how to represent arrays in C++? First, we need to declare the size, and I will go for a variable called size, and we will assume that we are creating an array of 5 integers. And so here we have, it's an array of integers, so we specify the type of the variables that we intend to store in this array. Now, whenever we create an array, all the variables within this array should be of the same type. We cannot create an array of integers and doubles at the same time. We cannot create an array of integers and strings of characters at the same time. In other languages, this is possible. In C++, we have a single type for the variables stored in this array. There is another way around that if you want, but that requires advanced polymorphism techniques that you might see later on. Okay, so right now we are creating an array where we are only storing variables of type integer, and we need to name this array. So here is my first array. Now, so this is the name of the array. And to specify the size, we need to provide the size between the brackets. Now, C++ doesn't like that. And the reason is here, when I declare the size, I declare the size as a variable, while C++ requires me to actually declare the size as a constant. And by convention, constant should be capitalized. So actually, I just need to replace that, and the job is done. Now, what I have done here in line 10 is the following. I asked C++ to allocate memory space for 5 variables of type integer whose size is 4 bytes, as we know. So 4 times 5 is 20 bytes. So this is here we allocated 20 bytes to this array called my first array. Now, what is interesting about arrays is that we can actually access all the items within the array one by one. So now the array is declared, we just allocated the memory. It's like we declared a variable, but we didn't store anything. Can we instantiate the variables? The answer is yes. We can actually instantiate the variables within this array by accessing them by index. So here we ask C++ to actually create an array of 5 integers. So to access the first integer, we need to start with the first, okay, with the first index, which is 0. So we start from 0 up to 4. So here we can say, okay, 0. So we suppose we go for 88. Now, my first array, it's actually here 1 equals to suppose 75, so on and so forth. Okay, so I am allocating, I'm assigning a value to the variables in my array, and in this case I have 5 variables. I only assigned values to the 2 first ones, but I can do that for all of them if I want to. Okay, now can we do an assignment with the cin into a variable within the array? The answer is yes. So we can do cin and copy all this if you want. Now here I will be taking the input from the user, and I will be cout. Okay, sorry. Here we'll say, okay, 0, 1, 2, 0, 1, 2. So let's just ask this int, okay, and I will get the integer, and I will get the integer from the user and store it in the third, space within my array of 5 spaces or 5 variables. Now, can we display the result, the content of the variables? The answer is yes. So we can do cout. Okay, so here is my first array 0, and here is my first array. Okay, so just a space here, and I can do the same with the other variables just to see that the instantiation and the assignment of the values worked actually. So this is 1, this is 2, 1, and 2. Okay, so if we run the code now, okay, so I will give the third variable. So here the value of 44, I got 88 in 0, 75 in 1, 44 in 2, and the job is done. Okay, so we have another possibility. So we can say my first array, and here we are going to fill the third, or the fourth actually, the fourth cell with suppose something like that. We can write expressions with the values of cells. So here what we are saying that the value stored in the cell number 3, which is the fourth cell, is equal to the value stored in the third cell plus 10. Okay, so basically we have the value stored in the second cell, which is equal to the number we get from the user. Then we add 10 to that. And if we print this value, let's see what we will get. So here we have 3, and here we have 3. Okay. Okay, the value that we will give here is 10. Now my first value is 88, second 75 as instantiated. Number 2 is 10, number 3 is 10 plus 10, which is 20, and that's working. So let's look at the arrays from a different perspective. Now suppose we are declaring an array of 4 integers. So here we have int my array. I'll just use a constant here just to save some space. So here I just created an array of 4 integers, and so this array, this line of code, when I compile this line of code, right away I will allocate a space for 4 variables of type integer. So this is my first variable, my second variable, and third and fourth variables. Okay, so now these variables, these are just variables, nothing really other than that. What is different is that these 4 variables are contiguous, which means the location of these variables within the RAM actually is, everyone is right near the other. So unlike any variables that we create separately or independently from each other, where there is no constraint of location. First variable can be in a location, the other one can be in any other location. Here, since this is an array, the 4 variables that we create for this array, they will be contiguous in the space, and every one of these variables will be actually so here we have 0, here we have 1, here we have 2, and here we have 3. So actually the array looks something like that. If I want to access the first item, I just use, there is no name, specific name of the array, but the variable, actually what I have is the name of the array plus the index of that specific item within the array. So I can use 0, 1, 2, or 3. Now, so, I mean, that's how I access individual variables. And actually, since these are contiguous variables, we can, based on the location of the first one, find the location of the next ones. So then the second variable will be just right after the first variable, and after, actually, here, since this is an array of integers, I just need to skip 4 bytes. It's not that complicated. Since I know that actually the size of the array, the size of the variable is 4, I can actually skip three variables, which is 3 times 4 bytes, which is 12 bytes to reach the fourth variable, and so on and so forth. So it's just a simple arithmetic operation to locate the variables within the array, and that is why we call the access to variables within the array constant time. It takes almost exactly the same amount of time to access the first variable as to access the second, or to access the nth variable within the array. It's just a basic arithmetic operation to calculate where the location of these arrays with regard to the first variable in the array, which is actually my kind of sentinel here. With regard to the first variable in the array, I can actually find all the variables located within the array in almost exactly the same time. Now, we have seen how to fill an array cell by cell like this, but are there any other ways? Actually, there are other ways for filling the array, and one of the simplest is to say suppose now my second array, and now I will just say, okay, this is an array of 5 integers, and okay, so I'll just need to specify that. It's an array of integers. I open and close braces. 1, 2, 3, 4, 5. Okay, so this way I instantiated all the variables in my array with a single line. I didn't go, cell by cell, which is kind of tedious. Of course, I need the semicolon at the end. Now, if I'm doing I'm doing the filling the array this way, I also can do exactly the same thing in my third array. Now, I don't need here to specify the size of the array. So I can say 11, 22, 33, 44, 55, something like that. Okay. So I may specify the size, or I may not specify the size. If I can't, here I'm using a constant, I can use a constant variable, a constant int, and use that. It doesn't change a lot. Now we have seen how to do that with integers. Can we do the same thing with, for example, an array of characters? So we will go for name here. So suppose I am creating a name of someone. So I will say my name here, and suppose I will say 7. This way, actually, I need to specify suppose I will go for Charles. I don't know how many characters. So here we have 1, 2, 3, 4, 5, 6, 7. So it's actually 7 characters, which is fine. So we have now an array with 7 characters representing the name Charles. Now, can I do something better? Yes, we can do something better without specifying Charles. Now, we just say here 2 and name 2, and I don't need to specify the 7, the size, because right away the size will be counted from the number of items that I have used to instantiate the cells of the array, and the job is done. Okay, so that's fine, but for an array of characters, as you could see, it's a little bit tedious to write the cells character by character, single space, single space. That's a bit tedious. Now we can see the third way. So it's actually this one. Sorry, it's equal. We can use this. So right away we can actually create an array of characters out of this string of characters. We can also use a string without the braces if you want. So far we have seen how to instantiate the variables of an array. Now, how can we do the printing or the display of the content of an array? So the first thing that comes to my mind is doing something like that. Okay, so, and I need another space here. So here we have okay, name one, okay, so let's here just 2, 3, and 3. Okay, so this is name 3. Okay, let's see here what happens. First, name 1, we have this weird ending of the string. Name 2, we have also a weird ending of the string. Name 3, it's better because we don't have any, it's just the name Charles is printed, nothing more, nothing less. Now, why we have this weird ending of the strings in both cases? The reason is simple. Now, behind the scenes, C++ will use a loop to actually print the content of the array. Now, C++ here learned that we have 7 characters, but yeah, this number of characters is not enough for the for this array. It's true that we have 7 characters, but in C++ and in C, by the way, every string of characters should be terminated by the null character, and this null character is \0. In this specific case here, since I am having a space for 7 characters, C++ will not be able to insert the \0 automatically, and in this case, C++ will not understand, will not see the end of this string of characters, and that is why I have these weird characters, is because C++ printed other characters that are empty, that are free in the memory, and I got this, chaotic output. Now to fix that, I just need to say at least 8 characters. Right now, if I print, I will not see anything more because C++ will have enough space to add the \0 automatically and fix the issue. Now in this case here, C++ just also did the allocation of the 7 characters that are here, but it did not have the automatically allocated space for the \0, and I cannot specify 8 here because by definition I didn't want to count manually. Now to fix this issue, I just need to add the null character, which is the \0 here, and the job is done. Here, C++ could automatically generate the string correctly with the \0, and I don't need to do anything because there is no issue to fix. Now, if we run the code, we will see Charles, printed correctly 3 times, and that's the, desired behavior of the program. Now, okay, so far so good. We could print an array of characters. That's great. And again, we could do that because C++ could, tell the beginning and the end thanks to the \0. Now, when we have an array of numbers, There is no backslash 0, but can we do the printing or not? Let's try to do that. Now let's do second array. Uh, if I print an array, I get a hexadecimal number. So this number is actually the address of the first variable of the array, and there is no way I can print the content of this array or this array using the procedure that we use with the string of characters, with the array of characters, because again, with the numbers or with any other types of variables like doubles or short or whatever, we do not have the backslash 0 as an indication of the end of the array. Now, how can I do that? Actually, we can print the content of an array of numbers using a loop. And to do that, I will just go ahead and say, okay, void print. I will define a function that will print an array for me. Now, how to pass an array as a parameter? Actually, so we need here to say, okay, this function takes an array of integers. So here it's an array. Okay, and we need also to specify int size of the array. Okay, you call the variable whatever you want. Okay, so here this function prints okay, so we just need a for loop, and this for loop actually int I equals 0, I smaller than size of the array, I plus plus. Okay, so basically here I would just say cout something like excuse me, current cell I need a space and here we have array I. So what we are doing is the following. So when the value of I is 0, we will take array 0, which is the first cell in the array. I is incremented after the first iteration, and now I print the second cell, which is array 1. Array I is incremented, third cell, so on and so forth. Whenever I reach something that is smaller than the size of my array by 1, which means size of my array minus 1 specifically, I will stop. I'll just print that and then stop my loop, and the job is done. I would have printed all the content of my array. Now this function is declared. I just need to declare the prototype of this function, and I also need to print this function, to call this function, excuse me. Now to call this function, we just do this. I don't need this line anymore. Now the name of my array is actually, suppose I will just go for my second array. The name of the variable here does not need to fit with the name of the variable here. As long as it's an array of integers is fine. And the size of the array, so here I will just go for okay, I'll just go for this constant if you want and use it here. It's better to use a variable than, it's not a good idea to use numbers or constants like that. So, and now I will pass the number 5 here. Okay, so, and the type of course is not needed. So if we run the code, we get current cell 0 is 1, second current cell 1, 2, so this is actually what I have here. Now let's try to print the other array, or which is my third array, which has the same size actually. So if we do that here, 11, 22 up to 55. So actually I could print both arrays with the same function because both have the same size in this case, and the job is done. So a loop was all I needed to actually print the array. Now, can I fill an array with a function like this? Of course, yes. So we can use a loop to fill this array. Now we just need to say void fill array. We can fill an array with whatever you want, but I mean, here I'm going to fill an array with input from the user. And so I will take exactly the same thing. Of course, here we have an array of integers, and we need to know the size. And I will need to also use a loop, a for loop that starts from 0 up to the size, of the array -1, increment by 1, all that. I need to do all that. Here I will just need to something like this. Now I just need to do cin and cin array I. So I go start with the first cell in my array. I will start with the first say of my array, which is the 0th one. Take a value from the user, iterate, take the second one, so on and so forth until the end of the array. Okay, so now we need to fill the array and then print the array. Okay, so just need to do the prototype first, of course. Now here we have that, and we need to declare an array and my fourth array, and we have the size of this array is size. Now what I will do is call my function fill array. It takes my fourth array as a parameter. This is the array, so we don't need to actually, when we call the function, we don't need to use the bracket squares, the square brackets, sorry. We don't need to use the square brackets because C++ will understand that this is the name of the array, and the name of the array is actually the address of the first variable in the array. So that's all what we need. Now we need to print the fourth array. Now if you run the code, let's see. Now we have 7, 8, 9, 10, 11. So 7, 8, 9, 10, 11. The array is actually, is instantiated and printed with these two functions that we define with the help of two different for loops. Now let's take another example with a function with an array. This function is really simple. It just finds the largest item within an array. So here we call this function find max. And find max, like the other functions that we have defined, takes an array of integers and takes the size of this array as a parameter. I'll just call it size, array size, just to be consistent. Now here as well, we need a for loop. For loop starting from I, int I equals 0, I smaller than size array, okay, and I plus plus. Okay, so basically we have all the ingredients now for our function, but actually the goal of this function is to find the max. And how can I find the max? I will do that with the simplest approach, which is I will start by saying, okay, my max, but the largest item initially is a very, very small number. I can do that. A second approach, more efficient approach would say, okay, int max equals array 0. Now, we can say, okay, for every item in the array, we will compare the current item to the current max. If the current item is larger than the max, we will update the max so that the current item becomes the max. If the current item is not the largest, is not larger than the max, we will keep the max unchanged. So if every iteration we will check if the current number is, if array I, so the current item in the array is larger than my max, what I will do, max is equal to array I say my current item is the max, and when I reach the end, when I have visited all the items in my array, max will be the largest item in the max. Okay? Now, after that, I will return max, which is an integer, and that's compatible with the type, with the return type of the array. Now, there is a small issue with this function. Now, here I'm saying, okay, the max is equal to the first item in the array. Then I will compare the first item of the in the array with the first item in the array, which is the max, temporary max actually. So here my first operation is redundant within this loop. To avoid that, I can right away start with the first item, with the second item number 1, just to do a relevant comparison. And I would save a single operation here, which is okay, not that big, but it makes more sense. In computer science, we hate redundancy. We don't like the computer to do anything unnecessary, and that's a simple thing to make the code a little bit more efficient. Now that we have defined this function, find max, we need to declare its prototype, and we need to call it from the main. Now I'll still keep it the same array, just I will just here do a new array that I will fill myself with input from my, from the user or myself, if you want. Now the max needs to be stored in a variable of fourth max. I will just call it fourth array max or whatever you call it. So here I have a variable of type int, because this function find max will return an integer, which is the largest number, and I will take this number. Okay, just this max. I'll print fourth max. Okay. So here we have, suppose 4, 9, 11, 2, 0. Now the max is 11, which is the correct answer, and the job is done.